Welcome to the interactive training module on the Turbochef ENCORE Rapid Cook Ovens. In this module we'll cover the systems and components used in these ovens. We'll go over how to operate the units and the sequence of operation. You'll use simulated tools and instruments to test components, troubleshoot and diagnose problems. The Turbochef ENCORE oven uses patented technology to rapidly cook food while maintaining food quality. This model has 2 magnetrons and 1 impingement blower. The control system precisely regulates the impingement airflow with the side-launched microwave energy. This control allows for a wide variety of foods to be cooked quickly with excellent results. The integral catalytic converter allows for ventless operation in most installations. So let's go on to the next lesson. In this lesson we'll go over scenarios you may encounter while servicing Turbochef ENCORE ovens. Many of the problems will show themselves with a fault code that's shown in the display. There are 9 numbered fault codes, however, each one may have more than one cause. They are numbered in by priority, and if a problem triggers more than one fault code, only the lowest number will be displayed. Most fault codes will terminate a cooking cycle when they're first registered, and operation cannot resume until the problem has been resolved and the fault code cleared. When fault codes F6, F8, and F9 are discovered, they are logged but won't stop a cooking cycle. We'll go through several of these and test the components with virtual tools to simulate real-life situations. From time to time, we'll use the test mode of the oven to troubleshoot various components and circuits. Let's start with fault code F1, blower. When the display shows F1 blower, it means the controller has determined the blower circuit isn't working properly. This can be due to a physical obstruction, such as debris, or a bad motor bearing, anything that would keep the motor from turning freely. It could also be a winding problem with the motor. Put the oven in test mode and turn the blower on. Listen for any noisy bearing or fan imbalance. If the blower seems unusually noisy, remove it and inspect it visually. Remove any debris or buildup on the fan blades. If the bearings are noisy or if the fan doesn't turn freely, replace the blower motor assembly. To check the motor electrically, at the BMSC, remove the connection to the blower motor, marked J5. Click on the buttons to test the different points. With your multimeter set on the ohm scale, test between the red and black wire terminals in the plug. You should see between 2.0 and 2.6 ohms. With your multimeter set on the ohm scale, test between black and white. You should see between 2.0 and 2.6 ohms. With your multimeter set on the ohm scale, check between red and white. You should see between 2.0 and 2.6 ohms. With your multimeter set on the ohm scale, check between green and each of the other wires, red, white, and black. Here you should see an open reading for each. Next you'll need to test the blower motor speed controller. To test the BMSE, the oven must be plugged back in. Be careful, there will be live circuits. The next test requires using the test mode. To enter the test mode, first press the info button. Press the down arrow to move to the second screen. Press the soft key next to test mode. Enter the password, 94288. You're now in the test mode. Across the bottom of the screen are some letters. Look to see if A has a flashing backlight. That stands for air. The backlight means it's off or the circuit is running properly. If there's a flashing backlight, it indicates there is an issue with that part of the circuit. Check the control wiring harnesses at J1 on the BMSC. Unplug the control harnesses and with a jumper wire, ground pin number 5 on the connector to the chassis. Does the flashing backlight go away? If not, you need to check the wiring back to the board. If there are no breaks in the wire, and no loose pin connections, the main control board should be replaced. However, this time it does go away. Now, we need to see if we're getting voltage from the main control board. With pin 5 still grounded, and your multimeter set to DC volts, test between pins 1 and 2. Go to the keypad display that's still in test mode. Press the soft key next to top blower 10% to increase the blower speed in 10% increments. Each increment should increase the voltage output from the main control board by 1 volt DC. If you don't see the correct voltage, check the wiring harness, and if that's okay, replace the main control board. There are other reasons you might see an F1 fault code. A fluctuation in the power supply, like from an electric storm, can cause the oven to register this code. Also, an overheated blower motor speed control, due to a clogged air filter or failed cooling fan, can trigger an F1 code. The oven will display an F2 fault code if the oven temperature falls 84 degrees Fahrenheit, or 47 degrees Celsius, below the set point temperature during a cook cycle. This is often a problem with the operators leaving the door open too long while loading and unloading food. However, you might see an F2 if the high limit thermostat has tripped and turned off the heating elements. Reset the high limit and see if the oven heats up. If the high limit isn't tripped, you'll need to check the heating elements. First thing to do is test the current on the heaters. Go to test mode, run H2. Do you have current on K4? If not, then inspect the bottom heating element. Then run H1. Do you have current on K5? If not, inspect the top heating element. To access the heating elements, first unplug the oven and perform a lockout-tagout procedure. Discharge the high-voltage capacitors. On the right and left side of the oven there are terminals for the top and bottom heating elements. Check for loose or burnt heater wire. This could be the problem. If you don't find that, remove the wires, and with your meter set to the ohm scale, test between the terminals. The top heater should have a resistance of 13 ohms, and the bottom 14.4 ohms. If either of them is open, replace it. If both elements test good, then you need to look at the solid-state relay. The heating elements are controlled by a dual solid-state relay. This test must be done with the power on, so be careful. Put the oven into test mode. With your multimeter set to DC volts, and one probe on B-, and the other on a known ground, press the soft key to activate the elements. If you see the signal go from 24 to 0 volts DC, the signal is good, and the relay is defective. Repeat this with the bottom element circuit, using A-. Another possible cause of an F2 is a faulty RTD. Since this is the device that's sensing the temperature in the oven, if it's malfunctioning it will provide bad feedback to the controller. If you see a temperature reading on the display of 999 degrees, the RTD is open and must be replaced. To test the RTD, remove it from the oven. Place the sensor bulb in an ice water bath for 2 minutes. With your meter set to the ohm scale, test the RTD. You should see a resistance reading of about 100 ohms. The controller monitors the current being drawn by the magnetron circuits using an induction coil mounted to the controller. Normal amperage will be between 12 and 14 amps at 240 volts, and between 14 and 16 amps at 208 volts. If the controller sees less than 10 amps, it will display an F3 fault code. There are several components in a microwave circuit, including the main control board, 4 relays, K6, K3, K2, and K1, a high-voltage transformer, a filament transformer, a high-voltage capacitor, a high-voltage diode, and the magnetron. We'll follow the sequence of operation to determine the problem. The K6 relay is the one that switches the voltage from 240 to 208 in North American ovens. In the case of a 208-volt unit, if it's not actuating, it could send 208 volts to the 240-volt primary windings of the transformers. This would result in a lower amp draw from the microwave circuits. Also, if the contacts inside the relay were bad, this could prevent one or the other of the microwave circuits from energizing. Make sure the K6 relay is functioning correctly. This brown wire carries the current for both microwave circuits. It runs through the induction loop on the main control board. With your amp clamp set to AC amps, place the jaws around the brown wire. You'll be turning on the microwave circuits, so put a load in the oven cavity. From the test mode, press and hold the soft key next to mag off. Look at your amp reading. You should see 12 to 14 amps at 240 volts, and 14 to 16 amps at 208 volts. Release the soft key to turn off the microwave circuits. If you see less than the normal operating current based on 208 or 240 voltage, you have a problem. Once the board has sensed 10 or more amps on the brown wire, the backlight behind the W at the bottom of the screen in test mode will go out. If you are pulling more than 10A and the W is not on backlighting, the control board will need to be replaced. If you're not seeing any amperage, it indicates that neither microwave circuit is getting voltage. First, check the F3 fuse to see if it's blown. If the fuse is okay, check the K2 relay to see if it's actuating. There's no voltage present at the high voltage transformer. Check the K2 anode relay. First, check for coil voltage from the main control board. When it's calling for microwaves, you should see 24 volts DC at the coil. If there's no voltage, check the wiring back to the main control board. No output means a malfunctioning board. With the correct coil voltage, the relay should actuate. If it doesn't, you have a faulty relay. If the voltage supply is present at both high voltage transformers and you're seeing low amperage, you have a problem downstream with one of the microwave circuits. To decide which one is the problem, unplug the oven and remove all 3 wires from the primary of one of the transformers. Plug the oven back in, and refresh the load in the oven. With your amp clamp set to AC amps, on the brown wire start another cook cycle. If you see the same low amperage reading, the problem is with the side you disconnected. If you get no current reading, the problem is with the other side. You'll need to test each of the components on the side that's not working. This can only be done with the oven unplugged and the capacitors discharged. Before testing a capacitor, first, make sure it's fully discharged. Once it's safe to handle, inspect the capacitor fully. Any swelling or leaking indicates a capacitor has failed or is about to fail. Capacitors are rated in microfarads. If you have a digital multimeter with a capacitance setting or a separate capacitance meter, touch each probe to a terminal and check the reading. Give the meter a few seconds to charge the capacitor and stabilize. You should see a reading in microfarads that matches the label plus or minus 10%. At this point, you'll need to check the capacitor for short circuits. Set your multimeter to ohms and test between each terminal and the outer case of the capacitor. Any reading other than infinite or open will indicate a bad capacitor. Before testing a high voltage transformer, make a note of the wire positions, then remove the wires. With your meter set to the ohm scale, measure between terminal 1 and 2. You should see between 0.819 and 1.001 ohms. Measure between 1 and 3 and you should see between 0.972 and 1.188 ohms. With your meter set to the ohm scale, measure between a chassis ground and terminal 4. You should see between 53.6 and 65.5 ohms. Any readings outside these specs will indicate a faulty transformer. Testing a filament transformer is done much like a high voltage transformer. Note the wire positions and remove the wires. With your meter on the ohm scale, measure between terminals 1 and 2. You should see between 17.49 and 21.37 ohms. With your meter on the ohm scale, measure between 1 and 3. You should see between 20.61 and 25.19 ohms. With your meter on the ohm scale, measure between 4 and 5. You should see very low resistance. If you see an open circuit, the transformer is bad. You can also test a capacitor with the ohm scale on your multimeter. Set your multimeter to the ohm scale. Test between any two terminals. You should get a momentary reading, then a slow return to an open or infinite resistance reading. Reverse the leads and you should get the same results. If you see a reading that doesn't change or an infinite reading, when you first connect your meter, you have a bad capacitor. Check each terminal to the case for shorts. Test a diode. First remove the wire going from the capacitor to the diode. Most multimeters can't read the high resistance to properly test high voltage diodes like the ones in microwave circuits, even if they have a diode test setting. So use a standard 9-volt battery and a jumper wire. The arrow in the diode symbol points to the positive side. Polarity is important in this test, so make sure you know which one of your probes is positive and which one is negative. The red probe is positive and the black probe is negative on this meter. Connect the jumper wire between the negative terminal of the battery and the negative terminal of the diode. Set the meter to DC volts. Touch the red probe to the positive terminal of the battery, and the black probe to the positive terminal of the diode. You should read somewhere around 5 to 7 volts DC. This voltage will vary with the output of the battery, but this indicates the voltage drop across the diode. Pause. Now swap your probes so that the red probe is on the positive terminal of the diode and the black probe is on the positive terminal of the battery. You should now read something like 0.1 volts DC. If you get these readings, your diode is most likely okay. If you see the same readings or an open circuit in both directions, the diode is bad and must be replaced. Normally, if all the transformers, diode, and capacitor all test good, and you're still having low or no amperage on one side, you can conclude that you have a magnetron problem. Visually inspect the magnetron for signs of arcing. If you see evidence of arcing, you'll need to inspect and possibly replace the waveguide cover, or both, before replacing the magnetron. If the magnetron looks okay, there are a couple of tests you can do to check. Make a note of the wire positions and remove the two wires to the magnetron. With your multimeter set to the ohm scale, test between the two terminals. You should have a reading that's less than 1 ohm. An infinite or open reading will indicate an open filament. Now test between each terminal and the magnetron outer case. You should see an open circuit here. Any resistance would indicate a filament that's shorted. Keep in mind that a magnetron that passes these tests may still be faulty if the correct amperage is present, but takes 5 seconds or more to reach its peak. It might indicate an issue with a weak magnetron. There are several possible causes for an F3 fault code. The bottom line is one or both of the magnetrons aren't firing correctly. You just need to figure out why. Fault code F4 will occur when the door interlock switches have engaged out of order with the monitor switch engaging first. The unit will blow fuse F3 if the monitor switch engages at the wrong time and the controller calls for microwaves. Check the fuse to make sure it's not blown. The order of the switch engagement can be viewed from the test mode. Across the bottom of the display are the letters P, S, and M. When a letter is highlighted, it means that the controller is seeing that the switch is open. Start with the door closed and open it slowly. As the switch is open, the letters will highlight in order P, S, M. Now, close the door slowly and watch the highlights go out in order M, S, P. If the switches are not opening or closing in order, they need to be adjusted or replaced. Look for signs of physical damage, such as a bent actuator tab or signs of arcing. If a switch is damaged, it must be replaced. One or more of the switches just may need to be adjusted. The primary switch is mounted in an assembly that's actuated by a striker mounted to the door. This assembly uses a spring-loaded pivoting cam-like device, called a toggle, to actuate the switch. With the door closed, check the angle of the actuator on the toggle. It needs to be between 85 and 90 degrees as measured from the face of the oven. Adding or removing shims between the assembly and the oven will move the switch assembly closer or further away from the door, and will decrease or increase the angle of the toggle. Adding shims will reduce the angle and removing shims will increase the angle. Adjust the secondary and primary switches, loosen their mounting screws and move the switch bodies until the primary switch disengages just before the secondary switch when the door is opened. Never allow the switch lever to rest against the body when the door is closed. This could cause an over-travel situation which will bend the lever or otherwise damage the switch. A small gap, about the thickness of a credit card, is all that's needed. Open and close the door several times to make sure the switches are working correctly. Press and hold the info key to reset the oven and clear the fault code message. Each magnetron has a snap disk thermostat mounted to it. It will open its contacts when it sees a temperature higher than 212 degrees Fahrenheit. Often, this fault is caused by a cooling fan or relay malfunction. It can also be caused by a blocked airway. Put a load in the oven and from the test mode, test the magnetrons. Verify that the cooling fans are operating and the magnetrons are working correctly. If both magnetron cooling fans do not turn, test the K7 relay to see if it's engaging. If only one fan isn't turning, inspect the wiring, and if needed, replace the fan. If the fans and the magnetron are working properly, look for debris buildup on the finger guards of all the fans. Also, check to make sure nothing is impeding the airflow in or out of the oven. Remove the debris and reposition the oven if needed. The F5 fault code can also be caused by a malfunctioning magnetron snap disk thermostat. With the oven unplugged and the capacitors discharged, remove the wires from the thermostat. With your multimeter set to the ohm scale, test between the two terminals. If the unit is cooler than the trip point, you should have continuity through the contacts. If you see infinite resistance, you have an open circuit and the thermostat must be replaced. Remove the magnetrons and inspect them and the waveguides for arcing. Replace any defective parts and retest the oven. If the fault code reoccurs, check the wiring and connections from the limit switch and control board. Fault code F6 happens when a thermocouple mounted to the main control board sees a temperature of 158 degrees Fahrenheit, or 70 degrees Celsius. This means the control compartment is getting too hot. An F6 fault code won't terminate a cooking cycle. If any of the inlet or outlet fans are obstructed, make sure this is cleared. If the oven is in a hot environment or too close to another heat-producing appliance, it won't have sufficient cool air to reduce the internal temperature. The thermostat should close its contacts and energize the cooling fans when it sees a temperature of 120 degrees Fahrenheit, or 49 degrees Celsius or more. Relocate the oven to a cooler area if needed. A cooling fan, thermostat malfunction, or the K2 relay can also cause this fault. If none of the fans are working, check the thermostat or wiring. If only one fan isn't turning, verify that it's getting power and if it is, replace it. The F7 fault code is triggered when the main control board has read the RTD as open. Unplug the oven and discharge the capacitors. Check the connectors at the main control board and at the RTD. If that seems okay, remove the RTD and test it by submersing the sensor in ice water for 2 minutes. At 32 degrees Fahrenheit, or 0 degrees Celsius, the RTD should have a resistance of 100 ohms. If the RTD reads infinite or open, replace it. If the F7 fault is intermittent but the RTDs test okay, the top RTD most likely has an internal breakdown and should be replaced. If the problem persists, The control board should be replaced. The F8 fault code will be displayed when the oven cooking cavity temperature isn't rising fast enough. During warm-up, the oven tests the temperature rise in segments. The main control board looks to see if the temperature rises at least 14 degrees Fahrenheit, or 7.8 degrees Celsius, in 30 seconds. If it does, the internal timer resets and continues to check each 14 degrees Fahrenheit or 7.8 degrees Celsius segment until the oven reaches 300 degrees Fahrenheit or 149 degrees Celsius. This fault is similar to F2 and may be caused by the same thing, and in some circumstances both codes may be logged. An F8 fault code won't terminate a cooking cycle and will just be logged. This code can be caused by issues with the blowers, heating elements, dual solid-state relay, RTD, the main control board, or the high-limit thermostat. Troubleshoot these components as described earlier in this lesson. Fault code F9 will be triggered when the RTD senses a temperature 650 degrees Fahrenheit, or 343 degrees Celsius, in the oven for a period greater than 40 seconds, but less than 2 minutes. One cause could be from buildup of grease, or other combustibles have caused the catalytic converter to flash. This fault will only appear in the fault log and will not be displayed. Check to see if the cook chamber is extremely dirty. If so, address the maintenance issue with the store manager. If not, the top RTD needs to be tested or replaced. A thorough oven cleaning is recommended. We'll cover that in the lesson on maintenance. The oven registers each fault code in its memory. To access the fault log, press the info key, and from the first screen, press the soft key next to the fault logs. Each fault code has all of the incidents listed by date and time of the occurrence. This history can help you put together a picture of what's going on with the oven. That's correct. That's correct. That's correct.